Welcome to Math's Magic. Let me ask you something right off the bat. Can you solve this real Cambridge IGCSE question without making the single most common mistake? Seriously, only a tiny top percentage of students manage to solve this one entirely correctly. Most candidates, well, they stumble right at the starting line, dropping incredibly easy marks because of one hidden trap. But today, I'm going to act as your personal premium coach. Let's dive right into this explainer and crack this open step by step. I am going to show you the absolute fastest examiner-approved method. I really want you to look at this question as a challenge. It's literally you versus the examiner. Can you get all the way to the final answer without falling for those classic pitfalls? Now, we are definitely going to reveal the best tactics, but I want you thinking actively this whole time. Pause if you need to, trust your math instincts, and let's see if you can beat the test.
Just to set the stage here, we are looking at the official Cambridge IGCSE Mathematics Paper 4 Extended from May/June 2015. And let me tell you, this isn't just any paper. It's a really rigorous assessment designed specifically to test your ability to synthesize entirely different areas of math. If you are an IGCSE, IB, MYP, or O-level student, this is exactly the standard you need to master.
And here it is, question 13, the ultimate challenge. Cambridge absolutely loves these multi-part problems. Notice how it seamlessly weaves together algebra, quadratics, geometry, and area concepts across 5 distinct sections? You can't just memorize one formula here. You really have to see how the whole mathematical puzzle fits together.
Okay, let's isolate part A. We are presented with a right-angled triangle. The vertical side is 2x minus 1, the base is 5x plus 4, and the hypotenuse is 6x plus 1. Now, the exact second you see a right-angled triangle with algebraic side lengths in an exam, an alarm bell should be ringing in your head shouting, Pythagoras' theorem.
Let's see exactly how this builds our equation. We set up our classic a squared plus b squared equals c squared. Then we carefully substitute our algebraic expressions in parentheses, so we get the quantity 2x minus 1 squared plus the quantity 5x plus 4 squared equals the quantity 6x plus 1 squared. Now watch carefully, because this next step literally changes everything. We are approaching a very, very dangerous algebraic trap.
Expanding these binomials, this is exactly where things so easily go wrong, and where examiners see most students just hemorrhage marks. Let's look at that first term, 2x minus 1 squared. Please remember, it is not just 4x squared plus 1. You absolutely must remember the middle term. It expands to 4x squared minus 4x plus 1. That negative sign is the trap. The others follow the exact same rule. 5x plus 4 squared becomes 25x squared plus 40x plus 16, and the hypotenuse squared is 36x squared plus 12x plus 1. It's simple, but you have to be meticulous to avoid those silly sign errors.
Next up, we bring everything over to one side to set the equation to 0. When you group your x squared terms, your x terms, and your constant numbers together, you get this incredibly satisfying final quadratic, 7x squared minus 24x minus 16 equals 0. And hey, notice how the question literally gave us the answer to verify in part A? That is Cambridge throwing you a lifeline. It's easy marks if you just keep your algebra organized.
Now for part B, we need to factorize this beast. We have a non-zero coefficient in front of the x squared, a 7. You know, you could use standard trial and error, basically just guessing brackets until something finally works. But honestly, under the intense time pressure of a real exam, that is just a recipe for panic. Systematic algebraic grouping is a far superior, bulletproof method. It takes the guesswork out entirely.
So here is how we actually apply this grouping method. We multiply our first and last coefficients. 7 times negative 16 gives us a product of negative 112. We need two numbers that multiply to negative 112 but add up to our middle term, negative 24. A quick logical check reveals those numbers are negative 28 and positive 4. We rewrite the middle term using these, giving us 7x squared minus 28x plus 4x minus 16. Group the first two and the last two, pull out the common factors, and beautifully we land right at our factorized form, 7x plus 4 multiplied by x minus 4 equals 0.
And this brings us to a really critical junction. Solving those brackets gives us two mathematical possibilities for x equals 4 or x equals negative 4 over 7. But remember, we aren't just doing abstract algebra here. This is a physical geometry problem. So which path do we take? I want you to pause for a second and use your real-world logic.
This is such a brilliant illustration of a fundamental rule for math exams. You must always check if your final geometry answers make logical, physical sense. Think about it. If we used -4/7 for x, our triangle sides would be negative lengths. You can't draw a line that's -2 centimeters long. Therefore, physical logic dictates we must entirely reject the negative value. We only keep x equals 4.
All right, now let's jump to part E, where we need to calculate that the area is exactly 84 square centimeters. We just substitute our valid positive x equals 4 back into the triangle's expressions. The perpendicular height, 2x minus 1, becomes 7. The base, 5x plus 4, becomes 24. The formula for the area of a triangle is 1/2 times base times height. Half of 24 is 12, and 12 times 7 is exactly 84 square centimeters. Boom! Easy, satisfying marks, as long as you remember to always use the perpendicular height.
Let's keep the momentum rolling right into part D. Now the examiner throws a totally new shape at us, a rectangle. Its dimensions are y and y plus 2. But we are told a critical piece of information here. The area of this rectangle is perfectly equal to the area of the triangle we just found. That means its area is also 84.
So we instantly set up our new equation. Base times height for the rectangle means y times the quantity y plus 2 equals 84. Expand that out. Y squared plus 2y equals 84. Bring the 84 over to make it a quadratic equal to 0. Y squared plus 2y minus 84 equals 0. We factorize this just like before. What multiplies to -84 and adds to +2? +12 and -7. So our brackets are y plus 12 and y minus 7.
Solving those brackets gives us two options, y equals -12 and y equals 7. But hey, remember our golden rule? We instantly reject the -12 because, again, geometry absolutely demands positive dimensions. Our final, rock-solid answer for the rectangle is simply y equals 7. Section 1. The Exam Trap. Top 3 mistakes. All right, let's take a quick step back from all the calculations for a second. Having marked papers exactly like this, I want to act as your personal examiner warning system. Let's look at the specific places where students consistently throw away their hard-earned marks. Here are the top 3 calculation and logic mistakes to watch out for. Number 1, simple sign errors when expanding squared terms with negative numbers. Slow down and write out every single step. Number 2, failing to logically reject negative answers. You have to always verify that your final geometry dimensions made physical sense. And number 3, guessing your factorization instead of using systematic grouping. Seriously, if you just eliminate these 3 errors from your workflow, your grades are going to instantly jump.
Section 2. The ultimate takeaway, mastering quadratics.
Okay, we've deconstructed the problem, we've found the solutions, and we've identified the traps. Now let's turn this into an actionable strategy to ensure you are totally bulletproof the next time you face a gauntlet like this. Here's your best revision strategy for mastering quadratic equations. First, absolutely master the grouping method for complex quadratics. It saves you time and completely reduces panic. Second, build a rock-solid habit of checking your final answers against physical logic. Just because the algebra works doesn't mean the geometry does. Finally, heavily practice mixed geometry algebra past papers. Cambridge is rarely going to test these topics in isolation.
So, as we wrap up this explainer, I want to leave you with a question. When you sit down for your very next study session and open up a past paper, what hidden geometry trap is waiting for you? Will you catch that negative sign error before it even happens? Apply this logical verification strategy today and just watch your confidence soar. Keep practicing, and I'll catch you in the next Maths Magic Explainer.